G'day, this is Bruce and welcome to my shop once again. I've just recently had a haircut, so I don't want to blind you, so I'll wear my Harris tweed cap. It's fitting anyway for thread repairs and so forth. What we're going to show today briefly is a Nissan GTR engine that's come in, and it has a series of threads that haven't come up when they've done the torquing, when they put the camshafts in, and the camshaft clamps over at the bearing clamps. These bearing clamps, they've threads have pulled. Not unusual for an aluminium head, and not unusual for motors like the GTRs where they push them pretty hard, and this one's been rebuilt a few times, I believe. So I've got 7 of these threads that I need to repair, and I'll swing around and I'll show you the tools that I'm using and explain a little bit about that, and then we'll swing it back around down and we'll have a look at me repairing one and options that we've got for doing the threading. So we'll go around here with the camera. Okay, and we'll come down. Actually, we won't. We'll stay up. We'll stay up here. It's nicer. All right. So now what we're using recoils or helicoils. There's many names for the same thing, but they're a wire coil thread insert. The threads are 6mm. And so we bore them out to the tapping size. We then tap them, and then we introduce the coil in and just check it to make sure it hasn't sprung or anything like that, and it's all good. These threads start down from the surface a bit, and when it came in and I opened up the first one to see, I could see that the standard inserts were too short, so I ordered the longer inserts, and I'll demonstrate the difference between what is standard comes into a package. So a coil set could come in a package like this, for instance. These are Recoil made by Alcoa. And they will have in them, normally they will have a thread tap, an application tool, and another tool for knocking out the tang. So that, and a drill bit. In this particular one that I use, this is in my vehicle, I also have an extra long drill bit that I use sometimes. Now, of course, the coils are not the only thing you can use. You can also use the Camshaft type. These are also made by Alcoa, by Recoil, and they're the ones that have solid steel with a series of pins in them that you screw that in, and then you drive the pins in, and then that locks it out. Anyway, the standard coil that you get, see if we can see it there. The standard coil you get is a 1.5D. That means it's 1.5. When it's stretched out, it's 1.5 times the length, the width of the thread. Now, sometimes I need a smaller one, so I have also these 1D, and in this case I needed a larger one, so I got a 2D. So we can have a look there at the difference in the height of the 3 of them, if we can stand them up. Well, they don't want to cooperate here. There we go. We'll see if you can see. So there we have the 1D, 1.5D and 2D. And these are the 2Ds. The one you could also get specially. You can get a longer one as well, but they'll go up to once they go past 2D, they normally go as a measurement length. I quite often have 2Ds in my vehicle, and then if I need a shorter one, I will cut 1 or 2 coils off to bring it into length. Sometimes the one that only have 1.5D, I might have to cut that as well, depending on the depth of the thread and so forth. In this case, we need the 2D. It doesn't cover the whole depth of the thread, but it gives it plenty of grip to satisfy the requirements of these threads. So we've got the tools now. What I've done here is I've had to, in some cases there are two. They've marked two of them that the threads have gone. So I've left the one screw in. I've taken the second screw out, and then I've drilled through. Use that second one. Use that as a guide to guide my drill down. It doesn't have to work. It don't have to do it like that. You can also drill it out, but then you need a square and check it and so forth. And in any case, when I'm doing the tapping, I use a small square, this type, or a regular square, and to make sure that I've always got the thread tap in the correct orientation. And thirdly, the other option is to make a guide, to make a drill guide, make a tapping guide. I have quite a few of those in the vehicle. In this particular case, it would have been a fair bit of work to make one up, and then once again you're guiding that hole. With these coils, they are a little bit forgiving, but not too much. And when you've got high pressure or high tension on them, then you want them to be as true as they can be, so that you've got equal amount of pressure along all the threads. So the other option I've got, I've got two options for threading. The normal standard tap that comes with them, they're called an STI tap, which is a standard thread repair tap. They are an intermediate. There are times when you need a butt tap, not often, because whatever happens, you've still got to have a little bit of thread down there, which will accommodate the tang, so you knock the tang out and get it out. The other option we use sometimes, and what I use, is this tap, which is a guide tap. It can pick up the old thread, ream a new hole size, and cut the thread at the same time. I have a series of these in the car, in the vehicle, that I use on sites. So that's another option, and then that will actually give you the guide. Notwithstanding, you should still be checking to see that it's true in both directions as you're advancing. The third thing in aluminium in particular is it can bind. It's fine shavings, and what I tend to do is to blow out continuously while I'm cutting the thread, and quite often, like in this case, I'll withdraw the tap at least 3 times, blow it out, clean it, put some kerosene on it. I use kerosene for aluminium. I find that it suits me. It's a lot of the different tapping fluids for aluminium actually have a certain quantity of kerosene in them anyway, so I just use the kerosene. I find that cheap and easy and quick, and so forth. So we'll move on, and we'll get the camera down, and we'll do. I'll show you how I drilled out that the first hole. We'll then take that bracket off, and we'll tap it and install an insert. We can then close that, put the bracket back on, bolt it through to the new and connect onto the new coil, and then we can drill a guide drill and carry on and tap the other one. I'll just do the one for this show. So we'll swing around to the engine, and we'll show you. So there's the engine. It's a 6-cylinder motor with 2 cams, and we're working on this one here, on this particular cam. So I'll just see how we go of coming in there, and we can see. Might have to come in a bit lower down. See, This is the first one. I've repaired that thread. This thread's okay. And we'll now, I've now gone on, I've repaired these two. Where are we? I've repaired these two. Now I've moved on to the third set, and we'll, I'll just open it out, I'll take it back a bit I think, so we can see some more thing, and I'll lock up the camera guide and we'll go ahead with doing that threading. Okay, so we've gone ahead, we've used that as a guide. We've drilled out the thread, the old thread. There wasn't much resistance there, I can tell you. We'll now take this off. I could use a ratchet, but I don't. Now we've got the tap, and we've also got this tapping handle, and in the end here we've got a where are we? Yeah, these tapping handles are different square drives depending on the size of the tap, and they've got a little O-ring in there to hold it and a little square below it, so that holds it, and it makes it quite easy to rotate it. That's a set. I'm not for pushing any brand, but this particular is all these ones here are from a set that comes from what they're called. I'm trying to see what that brand is. They're basically the blue point. That's there. We can see that there actually. This is from Blue Point, which is part of Snap-on. That's the name. So, okay, so we've got that. We'll spray a bit of Kero off camera into it, and we'll bring it down. This is the hole we've drilled, and we'll start the tapping process. Now I'll just get that started a fraction, and then we'll bring the square over, and we'll check to make sure we're there. Now we see that we're pressing, we're a little bit that way, so we've got to come down a fraction. And we'll check that. Now we're on line there, and I'll check it also in this direction. And we can see we're pretty good. So we'll just get that down a few more threads. We'll check again. Got to come down a bit more yet. Right, now in this process what I do is I try and blow it out a bit and get so that there's less resistance, because they can bind quite easily, the taps. And I'll run the tap back out, clean it up. It's got a bit of rubbish in there as well, so I'll blow that out. A bit more kerosene. And we'll go back in again. And once again I'm going to check it. You can't see on camera the other way, but you can probably see that there. You can see we're nice and square, and we'll keep going a bit more. Once again I'll blow out that. I'm wearing safety glasses, so not to be concerned. And down there. More Kiro. Don't have to use a T-bar handle like this, but it is quite handy. I do have some of these taps that I've made extensions on because the T-bar wouldn't go in, and I've had to work quite deep down inside, especially in automotive. There's all sorts of issues there. I've plugged up the orifices here, individual orifices, and they will have to clean this engine once they get it back, but that's a lesser concern for me. My concern is to make sure that the threads have integrity and we do the best job we can. I can't guarantee these threads because I don't know with aluminium heads, they can be stressed out so badly from overheating or overworking them. So especially in these type of engines, so that's completely up to the client to worry about that side of it, because I'm not I can't do a metallurgical survey on it or anything like that. I can only do a feel and how much resistance I get when I am cutting those threads will normally tell me if we're pushing out uphill as far as that repair work is concerned. Okay, so we've got down to the final bit. There's quite a fair thread on this one. Some people from time to time will put two coils one on top of the other. I don't believe in that. I think it's fraught with danger. That theoretically you should not have a problem in having those two one on top of another work okay. I've got full thread down to the bottom. So now we're going to introduce the insert. We're going to give it a little bit of Loctite. There we go. It's more than what we need, but most of it will get pushed out anyway. Now we need to go below the surface, so we're not going to be able to get all the way down with this applicating tool. In fact, we find that the little thread that it's got on the side here, this little screw, does interfere against the bearing. So we can only go down to about -2 threads, and then I'm using a second one, which I've pushed the bush all the way. I've pushed the bush all the way back. You'll excuse me for what's his name messing around here. So that, but if it's been tapped correctly and so forth, then there should not be a problem of those last threads, the top threads following through. If it's not tapped correctly, then they could jump. So we're down there to the depth where the thread should be. There's a counterbores on these other ones, but we won't need a counterbore here because the drill hole is the size of the counterbore, so that's taking that up. So I've got a little fraction more down there. That's it. And then we'll knock the tang out. There we go, the tang's out. Now that should blow out. If not, I'll introduce a little magnet. It's gone, she's out. So now what we'll do is we'll put the bearing cap back in. Right, that's the wrong side. That's the side that it was. So we're going to put the bearing cap back in place, screwing it in there nicely. We'll put the second screw in, even though we've still got to repair this thread, but we'll put that in order for us to be in line, and then so we can then tighten up the upper one. We'll tighten this one up when we know we're on song as a guide, so we can do that. I'll tighten that up take this one out. And then we can now drill that hole out using that as a guide. That's it. You see, that drilling was with very little resistance. We can now unscrew that out. That'll torque up nicely. Before it was soft, it was just sort of going around all the time. There we go. Okay, now that all looks good, and we'll carry on with that. Thank you very much for watching, and help us out with our YouTube channel. If you would like to buy one of these tools, they are available by sending me an email, and that's Getter Out Australia. I've made these for checking different gear heads. These ones here are for DP, and I'm making one at the moment now for metric as well. So thank you for watching.